We'll look at it the same way. We'll find first the lowest common denominator by writing out the prime factors. Again, if it just pops out at you, if you already know what the lowest common denominator is, you don't have to go through these steps. But if you're not sure, let's make sure we know how to get there. So I know when we looked at terms and factors, we said for a term such as 5x cubed, we could just write 5 and x cubed as the factors. And that's fine here as well, but let's be quite strict about it and point out that 5 times x times x times x are the prime factors of 5x cubed. Similarly, 5 times x gives us 25x, and of course, the prime factor of x is just x. So what's our LCD got to look like here? Well, it must have a 5 to be divisible by 5x cubed. And it must have 3 x's multiplied together. So I'll go ahead and write that as x cubed. In order to be divisible by the denominator of the second fraction, 25x, I need two 5's rather, at the same time. So I'll take 5, multiply it by x cubed, and make sure I multiply that by another 5. I need an x, and I've already got one. Similarly, for the last fraction, I've already got the x I'll need. 5 times x cubed is 25x cubed. Okay. So how do I get from 5x cubed to 25x cubed? Well, I'm just missing the 5. I need to multiply top and bottom by 5. So I find 30 over 25x cubed is the equivalent fraction to 6 over 5x cubed. And you should be able to go backwards and do that, right? 30 and 25 are both divisible by 5, and that gives us 6 over 5. All right, here we already have the 25, but we're missing a couple x's. How do we turn an x into an x cubed? Well, we multiply it by x squared. If we multiply the bottom by x squared, we better multiply the top by x squared. And 3 times x squared is just 3x squared. Here we're going to need 25 and x squared as well. We're missing pretty well everything, so we end up with 25x squared. The answer won't look quite as tidy here, but it still has a single denominator. And all we'll do is the arithmetic in the numerator. We'll have 30. And then what are we adding? We're adding 3x squared. I'm going to write it out carefully here. And finally, we're adding 25x squared. Extend my fraction line. Our last step is to ensure that we've simplified anything in the numerator that we can simplify. And we do, in fact, have like terms. 3x squared plus 25x squared is 28x squared. So we have 28x squared. This is a positive 30. So we'll say plus 30 there over 25x cubed. And finally, we've arrived at the last type of problem. Now we're adding and subtracting fractions that all sorts of nonsense going on. So these are rational expressions. Okay, we'll approach it exactly the same way. And in fact, maybe we'll look at the LCD for both of these examples before we go on to solve them. We're looking again at the prime factors. Prime factor for x, that one's straightforward, as I hope are the prime factors for 2x. 2 times x gives us 2x. But what about x plus 1? If you go back to the video on factors, you'll find that the entire piece is the factor, x plus 1. If you tell me that the factors are x and 1 and x the way I've written them, I would assume that this denominator was actually 1x, not x plus 1. So you'll find that x plus 1 is already prime, and we can't simplify further. Okay, so once we've found the prime factors, we're ready to put them together to find the lowest common denominator. Looking at the first, we need to have an x in the LCD. That's clear. And looking at the last one again, just because this one's a little bit easier to talk about than the middle fraction, we need to have a 2 and we need to have an x. Well, I've already got an x, but let's make sure we add a 2, a factor of 2, into the LCD. And then finally, we know we need an x plus 1, the entire unit. So we'll throw that in. Let's tidy this up a little bit. Usually we write numbers, then variables, and then anything in brackets. So the LCD, to be clear about stating this, is 2x and x plus 1. No more, no less. While we're at it, so before I complete the first example, let's have a look at the LCD for the second example. I'll write again the prime factors underneath each. So sure, this is 4. I was very tempted to write that away, so I will leave it. This is 4 times 2x minus 1. But is 4 prime? No. But if you wanted to leave it as 4, because it's easy, it's a small number, we know that the prime factors are 2 and 2, that's absolutely fine. So we can start to experiment. We can use intermediate steps that we're comfortable with once we understand how this process works. But strictly speaking, the prime factors for the first denominator are 2, 2, and 2x minus 1. Maybe to ensure that those stay as a unit, maybe we put brackets around those. Now looking at the second denominator, we have 2 times x times 2x minus 1 again. And then finally for the last one, we have 5 and 2x minus 1. So what is the LCD? Well, going left to right, it has to have 2 2's, which is where I could have written 4, because I recognize that once I get to the second denominator and see that there's a 2, if I saw a 4 written in the LCD, I would know that was good enough. In any case, that's 2 2's and the 2x minus 1. Looking at the second denominator, I need a 2, got one. 2x minus 1, got one. But I also need a solo x, which isn't the same thing as a 2x minus 1. So I'll make sure I multiply by x as well. And then finally, the only thing that's unique about the last denominator is the 5. Let's tidy this up. 2 times 2 times 5 is 20. We've got a single x and then the 2x minus 1. So for the second question, the lowest common denominator is 20 times 2x minus 1. Okay, now we're going to use the lowest common denominator to write equivalent fractions that all have the same denominator. This might take a fair bit of space, so we'll see if I can put both onto the same slide. We'll do the left-hand one more slowly than the right-hand one. All right, our first fraction is 4 over x, and we'd like to convert that into a fraction where the denominator is 2 times x plus 1. How do we do that? What do we multiply by? Well, this is where the idea of what's missing really helps us. We already have an x, but we don't yet have a 2. If I multiply 2 by x, I get the 2x portion. And we don't have the x plus 1, so we'll put that in as well. X times 2 times x plus 1 is in fact 2 times x plus 1, the denominator we want. So the idea of looking for the factors that are missing is really helpful here. What would our numerator look like? Well, it's 4 times 2 times x plus 1. Maybe you expand that right away, but I'm going to write that as 8 times x plus 1 for now, and then expand it in the next step. All right. Now we are subtracting. We're subtracting 3 over x plus 1, and we'd really like to turn that into a fraction that has a denominator, of course, of 2x times x plus 1. What do we need to multiply by? All right, we've got the x plus 1 part down, but we're missing the 2 and the x. So I'll multiply top and bottom by 2x. By writing it in this middle step, I can very clearly see what I'm doing, making sure that I'm not doing anything that will change the value of this fraction. I'm multiplying this fraction, 3 over x plus 1, by 1, because 2x over 2x is 1. So I'm allowed to do that. All right, 3 times 2x is simply 6x. And then finally, we're drifting into this last problem. Let me try to tidy it up a little bit. 1 over 2x. And we'd like to turn that into a fraction that has a denominator of 2x times x plus 1. And if you're starting to see places where you can skip steps, that's fantastic. But the first couple times that we do any of these examples, we want to make sure that we're following the steps quite carefully. Here we're going to multiply top and bottom by x plus 1. So our new numerator is 1 times x plus 1. And that's the hard part done. Because we know now, they each have the same denominator, we can write it as a single fraction. And all we're going to do is the arithmetic in the numerator, which here will involve some algebra. So we'll take 8 times x plus 1, the first numerator, and then we'll subtract the second, 6x, and finally add x plus 1. Just to be sure, I'm going to put that x plus 1 in brackets. This is important. If this was a negative, for example, rather than a positive, well, now you can see that we'd have to use distributive property. In any case, being a little bit overcautious, and that's fine. We're almost done, but what we should do with each of these problems is tidy up that numerator. We're going to leave the denominator in its factored form. I won't use distributive property to expand that, but if I expand using distributive property in the numerator, I'll then be able to simplify by collecting like terms. So I'll be able to tidy up the fraction. Using distributive property, I get 8 times x and 8 times 1, so we have 8x plus 8, and minus 6x, and then plus x and plus 1. Very close to reaching our final step, 2x times x plus 1. Too many x's in that denominator. Let's back up a little bit. X plus 1. And what does our numerator look like? Okay, collecting like terms, I have 8x minus 6x is 2x. 2x plus x is 3x. And then the numbers, 8 plus 1 is 9. And if you've covered some factoring, you might be tempted to simplify that top numerator, top part of the fraction, but we don't need to. That's a perfectly satisfactory final answer.
Okay, we had previously determined that the lowest common denominator for this second question was 20 times x times 2x minus 1. So let's put that into practice. So we're again going to convert each fraction into an equivalent fraction with the new denominator, and we really want that denominator to be 20 times x times 2x minus 1. So the question is, what do we need to multiply the fraction by? And again, we're looking for what's missing. Right? We already have a 2x minus 1, but we don't have an x, so we'll absolutely have to multiply top and bottom by x. And furthermore, we need to convert the 4 into a 20, and we do that by multiplying by 5. So in the numerator, we have negative 3 times 5x, or negative 15x. Look at the second fraction. Again, when I'm determining what to multiply by, I'm not looking at the numerator. I'm only looking at the denominator and deciding what I will need to multiply the denominator by to turn it into the LCD. The only thing that's missing here is, well, we've got an x, we've got a 2x minus 1. The only thing missing is multiplication by 10 to turn the 2 into the 20. So I multiply top and bottom by 10, and 5 times 10 is 50. Last one, 1 over 5 times 2x minus 1, and we'll multiply that. Well, what's missing? We have to turn that 5 into a 20. We need to add an x, but we already have the 2x minus 1 that's called for in the LCD. So what are we multiplying by here? Well, all we need is a 4 and an x. Negative 1 times 4x is negative 4x. And we know that we're almost done here. We'll write the fraction all over the same denominator. And in the numerator, I've got negative 15x plus 50 minus 4x. And I can actually tidy this up in one step by recognizing that I have like terms there. Negative 15 and negative 4 is negative 19. So I have negative 19x plus 50. And there's my final answer.
All right, 2 more problems that are very similar to the last 2, just to give us some extra practice. As always, I encourage you to pause the video, try these questions yourself, and I'll catch you at the end of them. Okay, first step, of course, is to find the lowest common denominator. The prime factors are, well, 3x plus 2. Anything else, if you indicate a 3, an x, and a 2, remember that I'm going to assume that those came from 6x. So 3x plus 2 is already prime. There's a 3 and an x in the middle term, and an x finally. So the lowest common denominator is 3x and 3x plus 2. Tidy up the bottom here. Okay. So we'll take the 4 over 3x plus 2. And what do we need to multiply by to get to the lowest common denominator? Well, all we have is the 3x plus 2, so we have to multiply top and bottom by 3x. Second fraction is 7 over 3x. And what are we missing there? Well, this time we have the 3x, but we're missing the 3x plus 2. So I know that this can seem confusing with the 3x and the 3x plus 2, which is really why I've written this problem. Remember that a solo 3 and a solo x are very different from the factor 3x plus 2. And finally, we're subtracting 2 over x. This x got a little out of control. This one's missing quite a bit. We'll have to multiply by 3 as well as by 3x plus 2. All we have at the moment is the x. But that's the hard part done. So now we're just going to work with that. Sure, we don't yet have the equivalent fractions, but we have the setup for them. We know how we're going to get there. So 3x and 3x plus 2 in each denominator. And now multiply the numerators. 4 times 3x is 12x. 7 times 3x plus 2. Well, maybe I'll write this out and then use distributive property in my next step. And here, negative 2 times 3x plus 2. I'll simplify a bit by multiplying the 2 and the 3. So I get 6 times 3x plus 2. Okay, now we know we're almost at the end because we can write all of this as a single fraction. We'll almost certainly have some tidying up to do in the numerator, some simplification, but our denominator is set. So reading from left to right, I have 12x plus 7 times 3x plus 2. So I can go ahead and write that as 21x plus 14. And here I have to be a little bit careful because I've got a negative 6. So I have to take this negative 6 and multiply it by the 3x. So that gives me negative 18x. And the negative 6 is also multiplied by positive 2. So I get negative 12. So make sure that you're applying the distributive property correctly there. Our denominator doesn't need to be changed. We can leave that. We don't need to use distributive property, but we will tidy up the numerator. So we have 12x plus 21x minus 18x. Gives us 15x. And positive 14 minus 12 is plus 2. And there's our first of the last 2 examples. And now for our final question. The LCD here is going to be x times x minus 1 times x plus 2. If I look at the prime factors of each of the denominators. Okay, so I'll have to take 2 over x plus 2 and turn it into a fraction over x times x minus 1 times x plus 2. These ones actually tend to be a little bit easier to do, even though there's quite a lot of writing to be done. But I can clearly see that while I have an x plus 2, I'm missing the single x and the x minus 1. So from that point of view, these almost purely algebraic examples can be a little more straightforward. You have to be a little bit careful when I'm simplifying the numerator here, so I won't do it all at once. I'll take the 2 and the x and multiply those together, and we'll use distributive property in the next step to keep going. All right, then I have 3 minus x over, this is great, I already have the x minus 1 and the x plus 2. So I only have to multiply top and bottom by x. And that gives us the desired denominator, I've given myself quite enough room here. And we have 3 minus x times x as our numerator. I'll be careful here and copy this down quite slowly. And finally, 1 over x, well, should have written that up here. 1 over x, that's missing both the x minus 1 and the x plus 2. So we'll multiply top and bottom by both. So we have 1 times x minus 1 and x plus 2 in the numerator, and of course the full denominator. Hard part's done. The rest is simply simplifying that numerator. All right, so in the first one, we've got 2x times x minus 1. So using distributive property, I get 2x squared minus 2x. Here again, I've got a negative that I have to be careful with. I can think of this as, I'll write it over here, negative x times 3 minus x. That's a more common ordering for those two factors. And then using distributive property, I get negative x times 3 is negative 3x. Negative x times negative x is positive x. And there we go. So we get negative 3x, and that's positive x squared plus x squared. So that comes from my second numerator. And then finally, FOIL on the last numerator gives me x squared plus 2x minus x and minus 2. So it's a big mess, but we have a lot of like terms that we can pull together. And again, I'm not going to expand the denominator. So I have 2x squared plus x squared plus x squared. So maybe I'll make a note that I've used those already. So we have 4x squared. Terms that have x to the power of 1 are the negative 2x, negative 3x, so that gives me negative 5x, plus 2x, so we're back to negative 3x, minus x is negative 4x. So we've used these 4 terms, and finally there's a negative 2. And we're done.